My name is Poeschko. I work on the Wolfram Cloud team, and I'll give a brief introduction to what the cloud is about, what we've been working on over the last year, and what new features you can expect in the future.
Hello and welcome, everyone. My name is Poeschko. I work on the Wolfram Cloud team, and today I want to talk about what we've done over the last year or so, and what new features you've maybe already seen, or what you can expect in the future. First of all, what's the Wolfram Cloud? I think it provides many different things. First of all, it allows you to work with notebooks and write Wolfram language code right in a web browser without having to install anything on your local machine. You don't need Mathematica, you don't need any browser plugin. You can just go to wolframcloud.com and get going. But even if you work with desktop Mathematica, it can be very useful to use the cloud as sort of a deployment target. You can share notebooks with others who might not have desktop Mathematica, whether that's individual persons or just the whole world, basically. And you can also deploy arbitrary web applications written in Wolfram language to the cloud. That could be notebooks again, but it could also be forms or APIs that perhaps even return arbitrary HTML. So you could build an actual web application which might not be using notebooks at all. So yeah, it's very versatile, I would say. To focus a little bit on just cloud notebooks, here are a few things you can do with them. And by the way, this is running in a cloud notebook right now. So you can see this is a web browser connected to wolframcloud.com. It just happens to be a notebook in slideshow mode running in the cloud right now. So you can enter some text as usual in the notebook interface. You can make evaluations as usual. Of course, it can be more complicated math that returns a formula like this. And one important thing is that this is rendered purely in the browser on the client side. So as opposed to an image, you can actually resize this and it adapts. So it's not just a bitmap rendering of this formula. Of course, we have support for 2D and 3D graphics, like this one. Don't see the cell brackets. And this is interactive. You can rotate this. You also support manipulates, like this one. So you could move around the locators and drag around the sliders. And this basically just works, again, in a web browser without any local installation. So yeah, that's cloud notebooks, and to get something into the cloud, you can just create things on the cloud in the first place, or from desktop Mathematica, you would use publish to cloud or save to cloud to get it onto wolframcloud.com. So now a few things that changed over the last year or so. First of all, we simplified the landing page and sort of the onboarding process, which I think is really nice. So now if you go to wolframcloud.com, if you're logged in, you see a much cleaner interface. And also if you're not logged in yet, so in this incognito window, you get a landing page which actually explains what's going on in the cloud, and then you have one way to sign up. And it's actually free, so to create a basic plan, you just need to create a Wolfram ID with your email address, and that's it, basically. If you then need more computing resources in the cloud, then you might have to upgrade to a paid plan. But even with the basic plan, you get quite a lot, I think. Oops. Oh, sorry. So yeah, we're not completely done yet, I would say, with this streamlining of products. In some sense, it could still be a little bit confusing what product you choose, but I think we've come a long way, and so yeah, this is quite good. As part of this, we've already changed the URL structure slightly, the URL structure of cloud objects. And I think this is something important to keep in mind when you work with the cloud. So I want to explain this a little bit. By default, what you get from functions like cloud deploy and cloud publish is a URL that has obj in it, like here. And that refers to what we call the object or the deployed view of an object. And this is meant to be the URL that you share with other people usually. So if you look at that, manipulate, that's the wrong one. It would look like this. It has a small header on top, but otherwise it's really just a notebook that you can interact with. Whereas in the environment view, you can also edit the notebook, and you can actually construct that programmatically using the option cloud object URL type to cloud object. So in this view, you get a little more header and then the sidebar here, and then you can actually edit the notebook here. So yeah, that's what we call the environment view, and that's also what you would get if you create a new notebook on wolframcloud.com. Of course, you get into this editing environment. There's a few key differences between these environments that are good to keep in mind. So this environment view is only available to authenticated users. So if you shared this link with someone else that has env in it, they would be asked to log in first before they can see the notebook. Whereas the object view, that's meant for public consumption, basically. So as soon as you have permission to see the notebook, so in this case it would have to be public, anyone could look at the notebook in the object view. As I've already mentioned, in the environment view, you can do pretty much anything that you have permission to with the notebook, so including editing the notebook, and if you have write permission, you can also save it back. Whereas in this object view, you can only read and interact with the notebook, even if you would have more permissions. There's also a difference in the kind of kernel that you get in each of these views. It's sort of a technical detail, but maybe you care about this. So in the environment view, you basically get a longer-lived session kernel, because the idea is really that you do some experiments, you define variables and use them later, as you would usually in a notebook session. Whereas in the public view, or the object view, you get what we call a public kernel, which is shorter lived, and you can't assume that it sticks around for a long time. Yep?
Is this still the same object? So if I'm
Yes. Great point. Yeah, it's really different views on the same object.
So could you change the URL in the browser and switch between
Yep,
them?
absolutely. So if I close this and now for some reason, it's usually not a good idea to have two versions of the same notebook open at the same time. That's a little caveat right there. And I think it actually showed this, but now I should be able to edit this. And if I wait for it to save, then I switch to the OBJ view now, and now I have this edit here as well. Yep.
Do these different views make any difference for non-notebook cloud objects?
It depends. So for instance, for an API function, you would usually only view it in the deployed view, right? That's where it actually executes. We think of this deployed view as sort of the thing you would usually use, like if you open an executable on your local machine, right? Whereas the environment view is the editing environment where you would have a richer interface that allows you to edit things. Yep.
Do you know if the OBJ/env kind of thing is documented anywhere?
So we did certainly document this cloud object URL type option now, but we certainly want to add more documentation about just what I explained now. It's sort of a higher level overview of how the cloud operates. That's something we still need to do, absolutely. And I also want to mention that it's usually not a good idea to rely on this structure of URLs in your code anyway. So it's certainly great to use a function like this where you use this option to change from one URL type to another, but you shouldn't make any assumptions about this URL other than that. So don't go in and fiddle with the string and adjust it somehow, because we might be making more changes to this URL structure in the future. Of course, we'll announce that and talk about it, but in your code, it's usually not a good idea to rely on that implementation detail. Yeah, and other than URLs and kernels, there's also a difference in terms of cloud credits. So in the environment view, it basically doesn't matter what you do. You have your single session kernel. You can do evaluations without having to worry about cloud credits at all. In the object view, that's slightly different. So if you have an API function or form function, for instance, they would always consume cloud credits as they execute. Part of the reason is, of course, that you could share something with the whole world, and it might be using lots of cloud resources in parallel if multiple users try to access the object at the same time. So we need to control for that somehow. At the same time, and Stephen and Andre have already talked about this as well, we realized that especially if you just publish a notebook, you usually don't want to worry about cloud credits. You just want to get it out there. And my internet, let's see what happens. Should refresh this. Does this just drop? You do need internet connection to work with the cloud. That's the unfortunate reality so far. So yeah, the idea is that as long as you publish a notebook, making it public, we would provide every viewer with a sort of complementary amount of cloud credits, so that you as the owner of the notebook don't have to worry about them. Once each viewer runs out of that limit, we might ask them to sign in or something, but it would never use your own cloud credits. So this is kind of a problem. Would it make sense to you try the other Wi-Fi, or is that hopeless? Okay. There it is again. Otherwise, I do have a local cloud installation. Okay. So, yeah. Mm-hmm. Right, so the question was about collaboration in the environment view. It doesn't work very well right now. Yeah, that is the unfortunate short answer. It's something we definitely want to support in the longer term, so that multiple people could work on the same notebook at the same time. Right now, it might be a bit unpredictable. Usually what should happen is that one person gets the lock on the notebook, and then one person can edit it. The others can still look at the notebook, and usually what might happen is that they even see the updates, but there is no guarantee for that, I'd say. Yeah, but definitely something we want to do in the longer term. Yeah. So now I just want to go over a few new features that we developed over the last year in Cloud Notebooks. Some of them are just to basically catch up with desktop and what's supported there. Others are actually unique cloud features, at least for now. And this first one is one of those. Part of the motivation was, though, to bridge the gap a little bit between cloud and desktop, because right now you can't edit typesetting constructs in the cloud as such. You can certainly evaluate something like this, and then you get something back that renders as a fraction. You can even copy that and paste it into an input cell, and then you can edit around it, so to say, but you can't go into this and edit just the numerator, for instance. But one thing we added so that you can enter these things into an input cell right away is this input form-based input. So you press Control-Shift-1, and then you enter what's called input form in Wolfram language, So for a fraction, that would just be x/y. Then you press enter, and it resolves to the fraction right in place. Now, if I want to edit this, I can just click it, and it goes back to this linear form again. And of course, this also has the right evaluation semantics, so I can, put this like this, and doing, yeah, and it treats it like a regular fraction, of course. A bit similar is evaluate in place, which does exist on desktop, of course. So if you select something in an input cell and press Command Enter on Mac, it resolves to the result right away. So that's also useful sometimes, and then you can keep working with it in the same cell. You've maybe already seen it. We also added something called click to copy. So if you have a result like this, you just need to click the output cell, and it's immediately on the clipboard. You can then paste it somewhere else and keep editing it. And part of the motivation was, again, that you can't really make a granular selection in here. So unfortunately, at this point, I can't select just the numerator of this fraction. So it just makes sense to copy the whole thing. We also added support for cell group openers and closers. So if you close a cell group like here, you get this new little icon and also the corresponding closer once you open it. We also added print to PDF. So in the file menu, you now have this item, and it will take a little bit because it takes this whole slideshow. But eventually, it should generate a nice PDF, which you could then print or share it with others. And in a sense, this is just another view of this cloud object again. So notice that instead of OBJ or env, we have PDF now here. So we might actually add this to the language level as well to easily construct such URLs in the first place. A few more things. We also added support for Unicode. So you can now, at least on Mac, press something like Control Command Space and insert Unicode characters or emojis in particular. And they also have the right evaluation semantics, so it treats this string as just having a single character with this code point. Yeah, you can also. Do you know a good code? Ah. Yeah. I was just going to show that. So that's the one caveat right now, is that under the hood, our editor is still sort of 16-bit based as far as characters are concerned. So you'll see that the cursor goes into this emoji now. If want to live adventurous, in a sense, yeah. So you could add something here, and it breaks up the surrogate pair. But don't do that. Yeah, so that's Unicode support. We also worked a bit on tokenization of code or text in general and the spacing around tokens. So this is a screenshot from previous cloud versions, and this is what you would see now. So notice that the spacing got a little more relaxed, and it's definitely more similar to desktop now. We also changed the font that we're using under the hood for rendering some of these special characters. There is still some small differences to desktop, but that might actually be bridged by changing the desktop, not the cloud. At some point, desktop might be using the same font we're using now to render these characters. So yeah, lots of things going on. I can't go into detail for all of them, but the overall focus of us has certainly been improve stability, robustness, and performance in the cloud. And two projects I wanna highlight in particular, because I think they're quite interesting, is first of all client-side graphics rendering. So far, what we did to render any sort of graphics in cloud notebooks was to use the server-side kernel and front end to generate some JSON data that we would then turn into an SVG graphic in the browser. And that was a good approach because it allowed us to support all sorts of graphics right away. But it did have that performance overhead of going to the kernel every time we render the graphic. So what we've started to build is a complete implementation of the whole graphics layer in the JavaScript front end. On the one hand, for better performance, obviously, but also on the other hand, to support, for instance, dynamic in places where it didn't work before. So in this case, we have a circle with a dynamic radius, like here, and then 2 other circles that are just sitting there statically. And then we also have a slider that changes that radius. So now you can see that updating dynamically. And that's something that didn't actually work before. You would have to wrap dynamic around the whole graphic expression, which then had also negative consequences for performance. So this is something that's starting to work well now. And in this case, for the simple dynamic, it doesn't even have to go back to the kernel, which is very nice. The only caveat is that so far we only support disks and circles. So it's a very small initial step on the surface, but under the hood, we really build out a nice framework, and we should be able to add more primitives quite soon. Will probably take a little longer to get to things like insets and axes, but the good thing is that there's always a fallback solution. So all graphics will certainly render in the cloud if necessary by using that kernel-based approach we have now. Right. The other performance project I want to talk about briefly is the compiler in the cloud. And this is not working quite yet, but in the next version of the cloud, we will have a working compiler. So you can do things like this. Now I can't use the wolframcloud.com because it's not quite there yet, but on my local cloud instance, I could create a new notebook and evaluate this, and this will do the right thing. So I can do something like this, and it just works in the cloud as well. So that's certainly good to speed up Wolfram language code in cloud kernels, but it will also allow us to build something which is, I already showed this last year. It's not done yet, but this is really the first step to getting this to work, where the idea is that we can compile certain manipulates. So need to enable this, and then if I take this manipulate, and I think I usually have to do it twice for some reason, but now what should be happening, maybe it's, maybe I was asking for too much. Yeah, I think it's quite smooth. So what's happening now is that it took this expression inside the plot, compiled it to WebAssembly, which can run purely in the browser without going back to the kernel, and it uses that to update the plot whenever I drag the slider. So this allows for very smooth interactions that don't suffer from the usual latency between the client and the server-side cloud infrastructure. So that's, again, a longer-term thing we're working on. Enabling the compiler in the cloud is the first step to that. I'm running out of time, so I can't go into too much detail, but we've also worked on this Wolfram Notebook Embedder library. You can go to the website, check out the documentation. It basically allows you to seamlessly embed notebooks on websites. And in terms of integration, we've also worked on integration into Google Drive. So you can go to Google Drive. If you have a notebook file there, just open it, and either you already have the Wolfram Cloud app connected, or once you do that, it will suggest to open it. Maybe we can do that really quickly. I can just say, open this with Wolfram Cloud. It will copy the file to the cloud, open it there. You can edit the notebook here if you want, and then save it back to Google Drive. That's also a nice integration, particularly for Chromebooks, for instance. So yeah, that's all I wanted to show today. Please reach out either by email or in community, where we try to be quite active. And also, if you want to learn more about each release of the cloud, we started to publish these cloud release notes, which have lots of detail about each of our releases. Looking forward to what you're all creating with the cloud, and thanks for your attention.